we are going to go through the 6 tasks assigned as a part of the GRIP May 2021 internship. I am using Python as my preferred choice of language. The problem at hand is to create a decision tree classifier and visualize it. We are provided with the IRIS dataset. Here I have imported all the necessary packages, namely pandas, numpy, matplotlib and seaborn, which is also a data visualizing package. Next, I have referenced the decision tree regressor module from sklearn.tree. I have also imported the input output function and then written the code so that I can print all the rows and columns of the data frame. Next, I have written this snippet of code to import the data set from the device and assign it to the variable IR. Then I use the .head function to print the top 10 rows of the data frame. The .head function usually displays the top 5 rows, which is why the number 10 has been mentioned. Since the ID column serves no purpose, I have deleted the entire column. Next, I have used the .head function to confirm proper deletion of the column. Then I have printed the .shape function to find the number of rows and columns present in the data frame. The .describe function prints the basic descriptive stats on the numerical factors present in the dataset. Next, what I have done is use the .info function, which helps us realize that there are no null values present in the data frame. The name of the data frame .column name .nUnique function returns the number of unique values present in the previously mentioned column, which in this case is species, and there are 3 distinct or unique species present in the column. Next, we import the dataset module and assign the dataset IRIS to the variable df. What happens is that we use the .target function to assign a unique numerical value to every set of species, namely 0 for Iris setosa, 1 for Iris versicolor and 2 for Iris virginium. Next, what we do is we import the linear regression module and reference the linear regression function as MLR. Using MLR as reference, we feed the 4 factors in the data frame such as sepal length, sepal width, petal length and petal width. Once the multiple linear regression has been fitted, we print the intercept and the coefficient of regression preceding each independent factor. Like this is the intercept and then these are the regression coefficient preceding each of the factors, namely sepal length, sepal width, petal length and petal width. Next, we consider the factors and print the top 5 values. We are only considering the factor values, and to show that only the 4 factors are being considered, I have used the .head function to print the first 5 values. Next, we import the decision tree classifier and fit it with the array of factor values and dummy values, where H is the data frame of factor values and Y is the set of all the unique or the dummy values which we obtained previously. Once the decision tree has been fitted, what we do is we print it, and to print it we import some of the data visualizing packages which would help us print a proper decision tree. And this is the decision tree that was created. This is a very efficient methodology even when the segmentation is not done properly or there is not much difference between the data points. Thank you for spending your time on my project.